So what we're going to do is a strategy for sketching the graphs. The first example just looked at getting a table of values. And a table of values gives you some points. And the more points you get, the more accurate you can be. Although some questions like this one might get a little bit annoying to get a lot of table of values because you have an x to the 4. So a main strategy that we're going to use for graphing our polynomial functions is going to be as follows. We are going to find all the x-intercepts and y-intercepts, well, there's only one. All the x-intercepts we can find and all the y-intercepts we can find. Now, the y-intercept will always be easy. In this case, you just plug in x equals 0, and your y-intercept in this case is equal to -6. So that's easy. But for your x-intercepts, you're going to have to factor. So what we're going to try to do in both of these examples is factor, and then the second thing we have to do, once we have all of our intercepts, we're going to be able to sketch it using our knowledge of end behavior. So what does that mean? This one's an x to the 4. That means it's an even function. Even functions act like parabolas. Because it's a positive x to the 4, it's going to act like a positive parabola. So you're going to be able to draw your x-intercepts and y-intercepts. Those will be your points. You know what the end behavior is. You won't know how low things go for maximums and minimums, but we'll see that in a second. Okay? So we already know what our y-intercept is. In order to find our x-intercepts, we're going to need to factor. How do we factor this? Well, we're going to plug in values until we get one that's equal to 0. So for example, if you plug in 1, because the possibilities are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Based on that last number, those are possible factors. So we're going to start with 1, because it's an easy one to figure out. 2 minus 1 minus 14 plus 19 minus 6 happens to be 0. So now we know that x minus 1 is a factor. So because f of 1 is equal to 0, x minus 1 is a factor, and we can use synthetic division. 2, -1, -14, 19, -6. And you put plus 1 here, bring down the 2. And so now we know x minus 1 multiplied by 2x cubed plus x squared minus 13x plus 6. So we've started factoring it. Trying other values. Okay, now if you tried, again, the last number of this 2x cubed is a 6. So again, the numbers you'd have to try are plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. You'd probably start with 1 and try it, and it actually doesn't equal 0. Then you'd probably try -1, and it doesn't equal 0. And you'd keep trying things until you find something that works. And if I call just this part p of x, like they've done in the notes there, then plugging in 2 gives you 0, which means that x minus 2 is a factor. So now you can do synthetic division of that part. 2, 1, -13, 6. You'd put a negative or a plus 2 out here. Bring the 2 down. 4, 10. Sure enough, it equals to 0. So now we can write We had found x minus 1 was our first factor. Now we've found x minus 2 is a second factor. And we're left with 2x squared plus 5x minus 3. And once you get to a quadratic, you can just factor that using your old techniques. It has to be 2x and x. If I want a plus 5 and this has to be negative, I'm going to make my outside plus 6, my inside minus 1. That gives me plus 5, and it still makes my last term negative. It's a tougher one to factor because if you had put, for example, if you had put the 3 here and the 2 here, you might have thought it worked because my inside is 3 and my outside is 4. No, that doesn't make. No, 3 and 1. Sorry, I'll do 3 here and 1 here. Then your inside is 3 and your outside is 5, or 2, which makes 5. But because it has to be a negative 3, then you're not allowed to add to get 5. How did I do that? Oh, scary. It's a ghost.
Then it goes away.
Yeah, that's what ghosts do. Okay.
There are a type of highlighters.
Okay.
Like pens that actually erase after like so many hours.
Yeah.
So people were saying you should lend people that kind of pen during the exam.
Ooh, that'd be mean. Anyways, so now we factored it, so now we know all of our x-intercepts, because if we make this equal to 0, then your x-intercepts are x equals 1, x equals 2, x equals 1/2, and x equals negative 3. So now we've found all of our x-intercepts, and we found our y-intercept. We can draw them, and we can use our end behavior to show what this graph is going to look like. X-intercepts of 1, 2, negative 3, and 1/2. Okay, and our y-intercept was negative 6. Now, because we have all of our x-intercepts and our y-intercepts, and because we know this acts like a parabola, we know that it has to start over here. It needs to go through this point. It's going to come through this point, through this one, and through this one. And this will be a sketch of this graph. What we don't know is how far down this point here goes. And you don't need to know that yet. And you don't know how high this goes or how low that goes. You don't know where those max or minimum points are. But you know that this is the general shape of the graph. So what did we do? We found our x-intercepts and our y-intercepts, and then we used our end behavior to graph it. What we're going to learn in our next example, in example 3, is what it looks like. Find your x-intercept sketch using your knowledge of end behavior. And I may as well add it here, even though you don't know what it is yet. Sketch using our knowledge of end behavior and multiplicity. So in example 3, we're going to learn about multiplicity and what that does to x-intercepts. But for right now, we're perfect. Now we're going to go and do this one off to the side. The reason I wanted to do them both is one of them was an x to the 4 graph, so I really wanted to revisit that factoring of an x to the 4 graph. And now we can do this x cubed graph off to the side. So how do we do an x cubed graph? Well, same thing, and the reason this one, I didn't want to do just this one is because this one is way easier than that last one. Okay? Why is this one so easy? First of all, if you wanted to find your y-intercept and plug in x equals 0, well, y-intercept is always easy to find. it's going to be 0. If you want to find your x-intercepts, you have to factor, and this one is really easy to factor. You don't even have to use any of the new factoring skills you have. First of all, notice it has a common factor. So if you want, you can take that common factor of x out. And then what you're left with is already a quadratic. So then you can use your factoring skills and so your x-intercepts are 0, -3, and 2. This is an x-cubed graph, which is an odd function. Does it make sense that your end behavior is going to act like a line, and because the coefficient, the leading coefficient is positive, it's going to act like a positive line? So now when we go to graph this one, we've got 0, -3, oops, not -2, 2, do them in different color, -3, 0, and 2. We know that it acts like a line like this, so it means it has to start down here. It's going to go through that point, and through that point, and there we have our sketch. Just make sure that you draw it carefully enough to go through each of the points. Nice. So, questions that you can do that are sketching ones like this are 7 and 13.